Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course. Access control models defined. Access control models are methodologies in which admission to physical areas and, more important, computer systems is managed and organized. Access control, also known as an access policy, is extremely important when it comes to users accessing secure or confidential data. Some organizations also practice concepts such as separation of duties, job rotation, and least privilege. By combining these best practices along with an access control model, a robust plan can be developed concerning how users access confidential data and secure areas of a building. There are several models of access control, each with its own special characteristics that you should know for the exam. Let's discuss these now. Discretionary access control. Discretionary access control, DAC, is an access control policy generally determined by the owner. Objects such as files and printers can be created and accessed by the owner. Also, the owner decides which users are allowed to have access to the objects and what level of access they may have. The levels of access or permissions are stored in access control lists, ACLs. Originally, DAC was described in the Orange Book as the discretionary security policy and was meant to enforce a consistent set of rules governing limited access to identified individuals. The Orange Book's proper name is the Trusted Computer System Evaluation Criteria, or TCSEC, and was developed by the US Department of Defense, DoD. However, the Orange Book is old and the standard was superseded in 2005 by an international standard called the Common Criteria for Information Technology Security Evaluation, but the DAC methodology lives on in many of today's personal computers and client-server networks. An example of DAC will be a typical Windows computer with two users. User A can log onto the computer, create a folder and stock it with data, and then finally configure permissions so that only she can access the folder. User B can log onto the computer but cannot access user A's folder by default unless user A says so and configure it as so. However, user B can create his own folder and lock down permissions in the same way. Let's say that there was a third user, user C, who wanted both user A and user B to have limited access to a folder that he created. This is also possible by setting specific permission levels. As shown in figure 11.1, the first properties Windows shows that user C, the owner, has full control permissions. This is normal because user C created the folder, but in the second properties window you can see that user A has limited permissions which were set by user C. Windows network domains work in the same fashion. Access to objects is based on which user created them and what permissions they assign to those objects. However, in Windows networks, we can group users together and assign permissions by the way of roles as well. More on that in the role-based access control, RBAC section. In a way, DAC, which when implemented in client-server networks, is sort of decentralized administration model. Even though an administrator still has control over most or all resources, depending on company policy, the owners retain a certain amount of power over their own resources, but many companies take away the ability for users to configure the permissions. They may create folders and save data to them, but the permissions list is often generated on a parent folder by someone else and is inherited by the subfolder. There are two important points to remember when talking about the DAC model. First, Every object in the system has an owner, and the owner has control over its access policy. And second, access rights and permissions can be assigned by owners to users to specifically control object access. Mandatory access control. Mandatory access control, MAC, is an access control policy determined by a computer system, not by a user or owner as in a DAC. Permissions are predefined in the MAC model. Historically, it has been used in highly classified government and military multi-level systems, but you will find lesser implementations of it in today's more common operating systems as well. MAC model defines sensitive labels that are assigned to objects, users and objects, files and folders, hardware devices, network connections, and so on. A subject's label dictates its security level or level of trust. An object's label dictates what level of clearance is needed to access it, also known as a trust level. The access controls in a MAC system are based on the security classification of the data and need to know information, where a user can access only what the system considers absolutely necessary. Also, in the MAC model, data import and export are controlled. MAC is the strictest of access control models. An example of MAC can be seen in FreeBSD version 5.0 and higher. In this OS, access control modules can be installed that allow for security policies that label subjects and objects. The enforcement of the policies is done by administrators or by the OS. That is what makes it mandatory and set it apart from DAC. Another example is Security Enhanced Linux, SE Linux, a set of kernel modifications to Linux that supports DoD-style mandatory access controls, such as the requirement for Trusted Computing Base, TCB. Though often interpreted differently, TCB can be described as a set of all hardware and software components critical to a system's security and all associated protection mechanisms. The mechanisms must meet a certain standard, and SE Linux helps accomplish this by modifying the kernel of the Linux OS in a secure manner. Like DAC, MAC was originally defined in the Orange Book, but as the mandatory security policy, a policy that enforces access control based on a user's clearance and by the confidentiality levels of data. Even though the Orange Book is deprecated, the concept of MAC lives on in today's systems and is implemented in two ways. Rule-based access control, also known as label-based access control. This defines whether access control should be granted or denied to objects by comparing the object label and the subject label. Lattice-based access control, used for more complex determinations of object access by subjects. Somewhat advanced mathematics are used to create a set of objects and subjects and define how to interact. Role-based access control, RBAC. Role-based access control, RBAC, is an access model that, like MAC, is controlled by the system and, unlike DAC, not by the owner of a resource. However, RBAC is different from MAC in the way that permissions are configured. RBAC works with sets of permissions instead of individual permissions that are label-based. A set of permissions constitutes a role. When users are assigned to roles, they can then gain access to resources. A role might be the ability to complete a specific operation in an organization as opposed to accessing a single data file. For example, a person in a bank who wants to check A prospective client's credit score would be attempting to perform a transaction that is allowed only if the person holds the proper roles. So roles are created for various job functions in an organization. Roles might have overlapping privileges and responsibilities. Also, some general operations can be completed by all the employees for an organization. Because there is overlap, an administrator can develop role hierarchies. These define roles that can contain other roles or have exclusive attributes. To think about it, did you ever notice that an administrator or root user is extremely powerful, perhaps too powerful, and standard users are often not powerful enough to respond to their own needs to fix their own problems? Some operating systems counter this problem by creating mid-level accounts such as power users, Microsoft, or operators Solaris. But for large organizations, this is not flexible enough. Currently, most levels of roles and special groups of users are implemented in newer operating systems. RBAC is used in database access as well and is becoming more common in the healthcare industry and government. Attribute-based access control, ABAC. Attribute-based access control, ABAC, is an access model that is dynamic and context aware. Access rights are granted to users through the use of multiple policies that can combine various group and resource attributes together. It makes use of if-then statements based on the user and requested resource. For example, if David is a system administrator, then allow full access to the data server admin folder share. If implemented properly, it can be a more flexible solution. As of the writing of this book, many technologies and organizations are moving towards a more flexible, context-sensitive, context-aware mindset when it comes to authentication and access control. Table 11.1 summarizes the 4 access control methods just discussed: DAC, MAC, RBAC, ABAC. Access control method key points: DAC, every object in the system has an owner. Permissions are determined by the owner. Access control key points: MAC, permissions are determined by the system, can be rule-based or lattice-based. Labels are used to identify security levels of subjects and objects. RBAC, based on rules or set of permissions involved in an operation controlled by the system. ABAC, context-aware and dynamic authentication, uses if-then statements to allow access. Access control wise practices. After you decide on an access control model that fits your needs, you should consider employing some other concepts. Some of these are used in operating systems automatically to some extent. Implicit deny. This concept denies all traffic to a resource unless the users generating that traffic are specifically granted access to the resource. Even if permissions haven't been configured for the user in question, that person will still be denied access. This is the default setting for access control lists on a Cisco router. It is also used by default on Microsoft computers to a certain extent. Figure 11.2 shows an example of this. In the folders permissions, you can see that the users group has the read and execute list folder contents and read permissions set to allow, but other permissions such as modify are not configured at all, not set to allow or deny. Therefore, users in the users group cannot modify data inside the folder because that permission is implicitly denied. Likewise, they can't take full control of the folder. Least privilege. This is when users are given only the amount of privilege needed to do their job and not an iota more. A basic example of this will be a guest account in a Windows computer. This account, when enabled, can surf the web and use other basic applications, but cannot make any modifications to the computer system. However, least privilege as a principle goes much further. One of the ideas behind the principle is to run the user session with only the process necessary, thus reducing the amount of CPU power needed. This hopefully leads to better system stability and system security. However, notice that many crash systems are due to users trying to do more than they really should be allowed, one or more than the computer can handle. The concept of least privilege tends to be absolute, whereas an absolute solution isn't quite possible in the real world. It is difficult to gauge exactly what the least amount of privileges and processes would be. Instead, a security administrator should practice the implementation of minimal privilege, reducing what a user has access to as much as possible. Programmers also practice this when developing applications and operating systems, making sure that the app has only the least privilege necessary to accomplish what it needs to do. This concept is also known as principle of least privilege. Separation of duties. This is when one or more person is required to complete a particular task or operation. If one person has too much control and completes too many portions of a task, it can become a security risk. The more people involved, the less the chance the job can be compromised. Checks and balances are employed to make sure that the proper equilibrium of users is maintained. One example of this will be the securing of a new network. There might be one or more security administrators in charge of doing the actual planning and a couple more doing the actual implementation, and finally another group for testing, or perhaps a third-party company will do the testing. Keep everything on the up and up. It all depends on the size of the organization and the internal trust level. Separation of duties can be applied to a single user. For example, if a user on a typical Windows computer, Vista or newer, has a specific set of privileges, but the user wants to do something on the system that requires administrative access, user account control kicks in and asks for the proper credentials to perform the actions of that role. If the credentials cannot be supplied, UAC blocks the action, keeping the various duties separate. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.